find the area of the region between these two graphs, we should go ahead and graph them. So this is just linear. We've got a y-intercept and a slope of -1. This one's a little harder to graph. If you know the parent function 1 over x, if you know it looks like this, that 4 just gives it a vertical stretch by a factor of 4, so it makes it hug the y-axis and the x-axis a little bit more. But we can just go ahead and plug in some points too. So if I plugged in 1, looks like we get a 4. 2 gives me 2. 4 would give me 1. And you could plug in more points, of course. But it looks like this. So the whole point of the question is to try to find this area in red, this area between the curves. Okay, so from our previous work, I could find the area under this green curve. So that would represent, I don't know if I want to color this. I'm afraid it'll get ugly, but I could find all this area under the green curve by integrating from 0 to 5 with respect to x, that function. So that would represent all of this area that I highlighted in yellow. Oh, there we go. That works okay. And if I wanted the area under this curve, which would be all of this, I could integrate from up here. Let me backtrack a second. Let me change the integration bounds here. It really only starts, even though 0 through 5 is like, I don't know, the part in quadrant 1, the part where the area is under the curve starts with x is 1 and end when x is 4. So same thing with this one. I'm going to integrate from 1 to 4 of that function with respect to x. Okay, and then so we've done that before. Area under this curve, area under this curve. So really just the big idea is if you want this area in between them, you would take this area under the top curve, which would give you, let me highlight that again, give you all of this, which is what I want, but it's also a little bit too much. And then if we subtract the area under this curve, that just happens to be how much I don't want. So if I subtract those, it's going to give me the area that I do want. It's going to give me this area in red. So you can always just do the area under the top curve minus the area under the bottom curve. So for us, so notice these have the same bounds. So I could push this together if I wanted to. We got a 5 minus x minus a 4 minus x dx. And then I can integrate each one of those, so this would be 5x minus 1/2 x squared minus 4 natural log absolute value of x. And so then we can plug in the 4, then plug in the 1, and subtract those, and then we should come out with our answer. So plugging in 4, 20, this would be 16 divided in half, 8, and then minus 4 natural log of 4. Plugging in 1, we get a 5 minus a half minus 4 natural log of 1. See, these make 12. Natural log of 1 is just 0 because e to the 0 gives me 1. So all this goes to 0. So this ends up being 4.5 or 9/2. And if we combine these two together, let's see, 12 minus 4 would be 8. So minus another half would be 7.5, which is 15/2 times 4 natural log of 4.